Hey guys, welcome back to the new videos of Coding Pi. We are on mission to complete 50 plus AI project. Today I am going to show you that how you can build Horoscope web application that predict your destiny. This is project 11 out of 50 plus AI project and we want you to be the part of this journey. So if you were new to our YouTube channel, then please hit like and subscribe button. So at first what we need to do, we just install all the required libraries which include Gradio, Request and Beautiful Soup. And as you can see, in my case it is already installed, so it says requirement already satisfied. And you may also notice that some of the file are also getting download, which is up to 150 MBs of file. And here as you can see, I successfully installed all the required libraries. Now quickly I used to move on to the next step. Here I used to import Gradio as GR for creating user interface for Horoscope web application. Next I import request module, which is used to send HTTP request to fetch horoscope data from a website. Next I used to import Beautiful Soup from BS4. This will be used to parse the HTML content and help us to extract horoscope text. And at last I used to import datetime from datetime. This will convert and process the date and used to determine zodiac sign from date of birth. Now after running this code, quickly I used to move on to the next step where I defined zodiac sign mapping. And here as you can see, first I used to define a variable called zodiac underscore mapping. Then inside a dictionary, I used to map each zodiac sign with a unique number. This step is quite necessary because website uses number instead of names. Next I used to define a function to get zodiac sign from date of birth. And here as you can see, with the usage of def keyword, I used to define a function named as get underscore zodiac underscore sign, where I used to pass one parameter, that is date of birth. Next, with the usage of dob.month and dob.day, this line of code gives month and day. Now quickly I used to store it to their corresponding variable, that is month and day. Next I used to define a variable called zodiac underscore date. This will contain list of month and day boundaries for each sign. Next, with the usage of for loop through zodiac underscore date variable. With the usage of conditional statement, I used to compare date to determine zodiac sign. Now quickly I move on to the next step where I define a function to fetch horoscope. And here as you can see, I used to define a function called fetch underscore horoscope with two parameters, that is dob underscore string and day. Next, inside the try and accept block, the usage of datetime dot strip time function, I used to pass dob underscore str and I used to define its format. This line of code validate and convert it into datetime object. Then I store it to dob variable. Then in accept block, I used to define the type of error, which is value error. Unfortunately, if any error will occur, then it will throw a message which I used to define along with return statement. Next, in order to get zodiac sign corresponding to their date of birth, this I used to call a function, that is get underscore zodiac underscore sign, where I used to pass dob. Then store it to the zodiac underscore sign variable. Then this variable is going to be passed on top of zodiac underscore mapping as index in order to get corresponding number. This number is going to be stored in sign underscore number. Next I used to construct the URL for horoscope.com. The usage of f-string formatting, then store it to their corresponding variable, that is URL. And inside the URL I used to pass day and sign underscore number, whereas day represent today, tomorrow and yesterday, and sign number represent the zodiac sign. Next, with the usage of request.get function, where I used to pass constructed URL, this will send a get request to a website, and whatever value that comes from a website, it will be stored in response variable. Next, with the usage of Beautiful Soup class, I am able to extract useful information from the raw data. So for that, I used to pass response.content along with html.parser. Then whatever data that comes after it, it will be stored in soup variable. Next, in order to get a particular horoscope text from a page, this is done with the usage of soup.find function, where I pass div and define their class, which is main-horoscope, and then finally I used to store it to the horoscope underscore text variable. Next, with the usage of if conditional statement along with horoscope underscore text, this will prevent error if a website changes its structure. This will ensure that code doesn't break if content is not available on a website. Next, finally in return statement, I used to formatted the response, which is quite easy to understand. One thing you noticed over here, that horoscope underscore text.p.text, this line of code is used to extract horoscope text from the scrapped HTML. And in next return statement, I used to leave a message if content is not available. Quickly I used to move on to the last step where I use Gradio for creating user interface. Now here, as you can see, first I used to define a variable called iFace. Then with the usage of gradio, I used to call interface class, and inside that first I define a variable called fn. Then I used to call fetch underscore horoscope function. Next I used to define a variable called input. Then inside the list I used to pass gr.textbox and gr.radio, where labels and placeholders are included. This line of code generates a text box with three options like yesterday, today and tomorrow. Next I used to define a variable called output. Then with the usage of gr.textbox, I used to create a text box for horoscope result. Next I used to mention title, that is daily horoscope. And finally with the usage of iface.launch function, I used to deploy the code on gradio. And here one thing you notice that share is equal to true. This makes that URL is publicly accessible. Now finally, as soon as I run the code, I will get the public URL, and after clicking on it, I will redirect to the public user interface. And here as you can see the entire UI, which consists title and two text boxes. One is for input and one is for output. And below the text box there is a filter, and next onward there is two buttons, that is clear and submit. Now quickly I used to fill the details inside the input text box and click on submit button. We will get the result in horoscope text box, and whenever you jump over the filter, it will reflect horoscope accordingly. So this is how you can build horoscope web application with the usage of web scraping. I hope this video is informative. Please do like, share and subscribe for more upcoming projects. Hello guys, welcome back to the new project of Coding Pie. In this video I am going to show you that how you can build machine learning web application that predict stock price. And this is project 12 out of 50 plus AI project. And guys, your support means a lot for this channel, because this will motivate us and push me to work on new projects. So please don't forget to like, share and subscribe our channel. Now quickly install all the required libraries, which include yfinance, numpy, pandas, gradio, scikit-learn, tensorflow and matplotlib. And here as you can see, I already installed all the required libraries, so it says requirement already satisfied. And some of the files are still in downloading, so it will take little bit of time. And finally I have installed all the required libraries, which is up to 100 MB of file. So quickly I will move on to the next step, where I used to fetch stock data first. So for this I used to import yfinance as yf. And if we're gonna talk about this, yfinance is a Python library that allows fetching historical stock market data from Yahoo Finance. Next I used to import pandas as pd, which is a powerful data manipulation Python library used for working with structured data. Next, with the usage of def keyword, I used to define a function called get underscore stock underscore data with two parameters, that is ticker and period. Ticker is nothing but it is a parameter that is used to represent the stock symbol. And here I also mentioned that default value of period is 5 year. Next, with the usage of yf.download function, where I used to pass ticker and period, this line of code will extract data up to 5 years, and this will be stored in data variable. Next I used to print the header with the usage of fstring. This I used to pass ticker inside the curly braces. Next I also want to show that top 5 rows of all companies data. This I used to print data.head function. Next I used to print separator for better readability. For this I used to print equal to sign up to 50 times, and /n adds new line before and after the separator. This log make easier to read when we used to fetch multiple stock data. And at last, in return statement, I want to extract close column from the data, because closing price are commonly used for analysis. And here one thing you notice, that data with double square bracket ensure that data frame should be written, not a series. Next I used to mention list of stock tickers, which include Apple, Google, Microsoft, Tesla and Amazon. And this is to be stored in stock underscore option variable. Finally I used to fetch and print data for all stock. So this could be done with the usage of for loop, where stock will iterate over stock underscore options. Then I used to call a function that is get underscore stock underscore data, where I used to pass stock. After running the code, I successfully fetched the data, and this is how the data look like. It include date, closing price, high price, low price, open price and volume price. Now quickly I used to move on to the next step, which is pre-processed data. So for this, from sklearn.preprocessing, I used to import min-max scaler. And if we're gonna talk about this, min-max scaler is a scaling tool from scikit-learn that is used for data normalization. Scaling is critical for machine learning model to treat all features equally. And min-max scaler ensure that all values are between 0 and 1. Next, I used to import numpy as np for numerical operation. Numpy provide efficient array operation and scikit-learn relies on it. Now, next I used to define a function with the usage of def keyword, that is prepare_data, where I used to pass one variable, that is data. Next I used to call min-max scalar class, where I used to pass feature_range, that is 0 to 1. 0 to 1 is a range commonly used for neural network like LSTM. Then whatever value that comes after it, it will be stored in scalar variable. Next I used to call scalar.fit_transform, where I used to pass data. This line of code perform scaling operation on top of dataset, and then it will be stored in data_scaled variable. Finally, in return statement, I used to mention data_scaled variable and scalar variable. After running the code, I used to move on to the next step where I create data sequence. For this, first I define a function, that is create_sequence, with the usage of def keyword, where I used to pass two parameters, that is data and time_steps, that is 60. This function will create input-output sequence for time series forecasting. So for this, I used to define two variables, that is x, y, with two empty list. Here x is nothing but it is a feature variable, whereas y is nothing but it is a target variable. X will store sequence of past price and y will store next price to be predict. Next, with the usage of for loop, I as variable iterate over the data to extract sequence. And one thing you noticed over here, that inside the range function, first I calculate the length of the data, then I used to minus time_steps minus 1. This line of code avoid index error by stopping early. Next, with the usage of x.append function, where I used to pass data with index I colon under the round bracket I plus time_steps, 0. This line of code extract a sequence of time_steps consecutive values. Each sequence in x serve as input to predict the next value in y. Again, with the usage of y.append function, where I used to pass data with index I plus time_steps, 0. This line of code record next value after each sequence as prediction target. Finally, in return statement, I used to convert it into an array. The usage of np.array function, I pass x and y to it. Now after running the code, I quickly move on to the next step where I used to build LSTM model. And here, as you can see, from tensorflow.keras.models, I used to import sequential approach. This helps us to create linear stack of neural network. Next, from tensorflow.keras.layer, I used to import LSTM and dense layer. LSTM stands for long short term memory layer, which is a type of recurrent neural network, and the dense layer is fully connected layer, which means that every neuron from the previous layer become input to the next layer. Next, I used to define a function, that is build_LSTM_model with one parameter, that is input_shape, and this parameter specifies the shape of input data. Next, I call sequential class, and inside the list I used to arrange different type of neural network. And as you can see over here, that first two layer is LSTM and the last two layer is dense layer. In first layer of LSTM, I used to define 50 units of neuron with return_sequence is equal to true, which means that it will return full sequence of output. Next is input_shape is equal to input_shape. This is correspond to the feature variable. In last LSTM neural network, I used to mention return_sequence is equal to false intentionally, means it will only return last output in a sequence. I used to add dense layer with 25 neurons. This helps the network to learn more complex pattern. And as we know that this is a type of regression problem, is why in last dense layer I used to pass one neuron. Next, I used to compile the model with the usage of model.compile function, where I used to pass optimizer as Adam, loss as mean squared error. This line of code set up the training process for LSTM model, and after this I return the model variable. Now quickly I used to move on to the next step where I used to train the model. For this, with the usage of def keyword, I used to define a function, that is train_model, where I used to pass one parameter, that is ticker. Then inside the function I used to call another function, that is get_stock_data, where I used to pass ticker, and then I used to save it to the data variable. This line of code will extract all types of companies data as per as ticker. And ticker represent the short term of company's name like Amazon, Google, Tesla and so on. I used to call another function that is prepare underscore data, where I used to pass data variable. Line of code normalize the stock market data. I used to store it to their corresponding variable, that is data underscore scaled and scalar variable. I used to call create underscore sequence function, where I used to pass data underscore scaled variable time underscore steps, that is equal to 60. This line of code will convert the time series data into supervised machine learning format. After this, I used to save it to their corresponding variable, that is x and y, whereas x represent the input sequence and y represent the output values. Next, I used to reshape the data of x into 3 dimensions. This I used to call x.reshape function. I pass x.shape with index 0. This will represent the number of sequence. Next is x.shape with index 1. This will represent the time steps. And finally 1, which will represent the single feature. And whatever value that comes after it, I used to save again to the x variable. Next, I used to call another function, that is build underscore LSTM underscore model, where I used to pass x.shape with index 1, comma 1. And that will be stored to the model variable. This line of code will return compiled LSTM model which is ready for training. Finally, with the usage of model.fix function, I used to fit the model on top of x variable and y variable with epochs value 10 and batch size equal to 16 and verbose equal to 1. This line of code will train the model up to 10 epochs with batch size 16. Here I have to mention verbose equal to 1 intentionally, because I don't want to show the result in a progressive bar. In return statement, I used to return model, scalar and data. Now quickly I used to move on to the next step, where I used to predict future stock price. For this, first I used to define a function called predict underscore future with 2 parameters, that is ticker and days. Here I mentioned the default values of day equal to 30. Then I used to call train underscore model function, where I used to pass ticker. Line of code will return LSTM model, max scalar which is to be used on top of dataset, and original stock price data frame. And finally, I used to store it to their corresponding variable, that is model, scalar and data. Next, I used to call a function that is prepare underscore data, where I used to pass data. This line of code will rescale the latest data using the same scalar. Then I used to store it to their data underscore scaled variable. Here one thing you notice that there is a underscore sign after the data underscore scaled variable. This is used to ignore the second return value. Next, with the usage of data underscore scaled with index minus 60, this line of code will extract most recent 60 days of scaled data. And I used to store it to their corresponding variable, that is last underscore 60 underscore days. Next, I used to reshape the data into 3-dimensional array. With the usage of last underscore 60 underscore days dot reshape function, I pass 3 parameters, that is 1, 60 and 1. This will represent batch size, time step and features. Then I used to store it to their corresponding variable, that is x underscore input. Next, I used to define a variable, that is prediction with empty list. This list will store future price prediction. Next, with the usage of for loop, I used to iterate for each day to predict. So for this, I used to call model.predict function, where I used to pass x underscore input with index 0 with index 0. This line of code will make prediction on top of input data. And here one thing you notice that there is a double index with 0. It will helps to extract a scalar predicted value. Then whatever value that comes after it, it is to be stored in pred variable. This value I am going to append it to the prediction list. The usage of prediction.append function, where I used to pass pred variable. Now next, with the usage of np.append function, where I used to pass x underscore input with their index comma pred comma x is equal to 1. This line of code will act as a sliding window that drop the oldest day and append new prediction value. This will maintain 60-day windows for next prediction. So whatever value that comes after it, again it will be stored in x underscore input. I used to perform inverse scaling on top of prediction value. So for this, I used to call scalar.inverse underscore transform function. I used to pass prediction value with the usage of np.array function. Also, I use reshape function with -1, 1 will ensure compatibility with inverse transformation. Then whatever value that comes after it, it will be again stored to the prediction variable. And finally, in return statement, with the usage of prediction.flatten function, this will return prediction as one-dimensional array. I used to move on to the next step, where I used to plot prediction. For this, first I used to import matplotlib.pyplot as plt. Matplotlib is a Python library which is used to visualize the prediction data. So for this, first I used to define a function with the usage of def keyword, that is plot underscore prediction with one parameter, that is prediction. Next, I used to initialize figure with the usage of plt.figure, where I used to pass figure size, that is 10, 4. This line of code will create a canvas with 10-inch wide and 4-inch height. Then with the usage of plt.plot function, where I used to pass prediction, and I also mentioned that label, that is predicted price. This line of code plot the prediction array as line graph on top of canvas. Next I used to mention X labeled as day and Y labeled as stock price. And I also called plt.legend function, which is used to show the label, which is a predicted price. Next, with the usage of plt.savefig function, where I pass prediction.png, this line of code will save the plot in a current directory as png file. So finally, in return statement, I used to mention file name as prediction.png. Now quickly I used to move on to the next step, where I used to create gradio web application. So for this, first I used to import gradio as gr. This is a library which is used to create a web interface. First thing first, I used to mention list of available stock options. For this, first I used to define a variable, that is stock underscore options. Consists the list of number of stocks. Next I used to define a function with the usage of def keyword, that is gradio underscore interface, where I used to pass ticker and days. Then I used to call predict underscore feature function, where I used to pass ticker and days. This is going to be stored in prediction variable. After this I used to make return in the form of plot. So for this I used to call plot underscore prediction function, where I used to pass prediction. Now quickly I used to define a variable that is called demo, where I call gradio.interface class. And inside that class I used to call a function that is gradio underscore interface, which is to be stored in fn variable. Next I used to define input list, where I used to mention drop down and slider. Drop down will be created based on stock options, and slider will be created based on days to be predicted. And finally I used to mention title and description for this application. And in last step I used to deploy the code on gradio with the usage of demo.launch function, where I used to mention share is equal to true. As soon as I run the code, I will get the public URL, and after clicking on it I will redirect to the public user interface. Now quickly I used to select the options from the drop down, then adjust the number of days, and afterwards as soon as I click on submit option, I will get the predicted result. So this is how you can build machine learning web application that predict stock price using LSTM. I hope this video is informative. Please do like, share and subscribe for more upcoming projects. Hello guys, welcome back to the new videos of Coding Pie. Today I am going to show you that how you can build facial emotion recognition system. Here you can learn about how you can apply face detection and recognize emotion on top of recorded videos. This is project 13 out of 50 plus AI project. So without wasting time, let's get started. And if you are new to our YouTube channel, then please hit like and subscribe button. First thing first, what we need to do, just install all the required libraries which is necessary for this project, which include opencv, Python, headless, NumPy, Gradio and DeepFace. Now as soon as I run the code, installation will start, and here as you can see, some of the file are already installed and rest of the file are getting installed. After installation all the requirements successfully, I will quickly move on to the next step, where I used to import all the required libraries which include CV2, NumPy, Gradio, DeepFace. Where CV2 is used for video processing, face detection and drawing bounding boxes, which is used for annotation. Next is NumPy for numerical operation. Then Gradio is used for creating user interface for machine learning model. And finally I used to import DeepFace to recognize emotions. After running the code, I will quickly move on to the next step, where I used to define video processing function. And here as you can see, with the usage of def keyword, I used to define a function called process underscore video, where I used to pass one parameter, that is video underscore path. The purpose of this function is to analyze video file, detect faces in each frame, predict the dominant emotion for each detected face, and generate output video with bounding boxes and emotion labels overlaid on faces. So for all doing this step by step, first with the usage of CV2, I used to call a video capture class, where I used to pass video underscore path. This line of code is used to open the video file for reading frames, and it is to be stored in cap variable. Next I used to define a variable called frames with empty list, which is used to store process frames. Next I used to load the opencv face detector. This first I used to define a variable called face underscore cascade, and with the usage of cv2.cascade classifier, where I used to pass cv2.data.har cascades plus cascade underscore frontal face underscore default dot xml. This line of code will load a pre-trained har cascade classifier for face detection. Next, loop through the video frames. The usage of while loop over the cap dot is opened. This will continue the loop as long as the video file is open. Next, I used to call cap dot read function. This line of code will read the next frame from the videos, and then it is to be stored in read and frame variable. And finally, with the usage of conditional statement, I used to break the loop if no frame is read. Next, I used to convert each frame to grayscale. So cv2 provide a function called cvt color. I used to pass frame comma cv2 dot color underscore bgr to gray. This line of code is used to convert the frame from bgr to grayscale, which is used for face detection. Then whatever output that comes after it, it is to be stored in gray variable. Next, with the usage of face underscore cascade dot detect multi-scaled function, I used to pass gray variable and set the scale factor, that is 1.3. This value controls that how much image is reduced at each layer. I used to set minimum neighbor, that is 5, which means that higher value reduce the false positive. Finally, whatever value that comes after it, it is to be stored in face variable. Next, I used to process the each detected face. So with the usage of for loop over the each detected face, I used to extract coordinates like x, y, w and h. Next, frame with index y colon y plus h comma x colon x plus w. This line of code will extract face region from the frames, and it is to be stored in face variable. Next, inside the try and exit block, I used to define a variable called analysis. Then with the usage of deep face dot analyze function, where I used to pass face comma actions and then comma enforce underscore detection, that is equal to false. This line of code will analyze the face to predict emotions. I also mentioned that action is equal to emotions, which signifies that only emotion detection is needed. And enforce underscore detection is equal to false, which means that it will allow the function to continue even if no face is detected. And finally, whatever value that comes after it, it is to be stored in analysis variable. Next, analysis with index 0 with index dominant underscore emotions. This line of code will extract dominant emotion from the result. And finally, it is to be stored in emotion variable. So I used to draw a rectangle around the face. For this, I used to call cv2.rectangle function, where I used to pass frame which represent images where rectangle will be drawn. Next is x comma y under the round bracket. This will represent top left corner of the rectangle. Next is x plus w comma y plus h under the round bracket, which will represent bottom right corner, where w is width and h is height of the rectangle. Next, inside the round bracket, I used to pass 0 comma 225 comma 0. This will represent the color of the rectangle in BGR format. Finally, I used to mention 2, which represent the thickness of the rectangle. Next, I used to put emotion label on top of face. For this, I used to call cv2.putText function. I used to pass frame comma emotions. Here, frame will represent the image where text to be drawn, and emotion represent the actual text string to display. Next is x comma y minus 10 under the round bracket. This will represent the bottom left corner of the text. Next, with the usage of cv2.font underscore harshi.simplex, this will represent the font type which is to be used for the text. Then 0.8 represent the font scale, and under the round bracket 0, 225, 0 represent the color of the text in BGR format. And finally, here I used to mention cv2.line underscore AA. This is used to represent the line type for a smoother edge. Next is accept colon continue. This line of code skip the frame if any error occur. And finally, with the usage of frames.append function, where I used to pass frame, this line of code append the processed frame to the frame list. And finally, with the usage of cap.release function, this will release the video file handle. Now quickly, I used to move on to the next step, where I used to save the process video. For this, I used to define a variable called height, width, underscore, and with the usage of frames with index 0.shape, I used to get dimensions of the video frame. I used to define a variable called output underscore video, where I used to pass process underscore video.avi. This line of code represents the output file name. Next, with the usage of cv2.videowriter underscore 4cc class, where I used to pass asterisk x vid. Line of code specify the video codecs, and whatever value that comes after it, it is to be stored in 4cc variable. I used to call cv2.videowriter class, I used to pass output underscore video, 4cc, 20, width, height. This line of code will initialize the video writer object as out as variable. Next, with the usage of for loop, I used to iterate frame over the frames. Then with the usage of out.write function where I used to pass frame. This line of code write each processed frame to the output videos. And finally, with the usage of out.release function, this line of code release the video writer. And finally, in return statement, I used to mention output underscore video. Now finally, in last step, I used to create user interface using gradio. And here, as you can see, first I used to define a variable called iFace. And with the usage of gradio, I used to call interface class where I used to pass fn as variable where I used to call process underscore video function. Next, I used to define inputs as variable where I used to call gr.video function where I used to pass label. Function will take input in video format. I used to define output as variable where I again used to call gr.video function where I pass label. I used to define title, that is facial emotion recognition, and description. And finally, with the usage of iFace.launch function, I used to deploy the code on gradio. And as soon as I run the code, I will get the public URL. Then after clicking on it, I will redirect to the public user interface. And as soon as I upload the video to the application and click on submit option, it will start processing. And finally, here as you can see, facial emotion get detected on top of recorded videos. So this is how you can build facial emotion recognition system. I hope this video is informative. Please do like, share and subscribe for more upcoming projects. Hello guys, welcome back to the new videos of CodingPy. In this video, I am going to show you that how you can import data from Kaggle and transform it into a machine learning web application. And this is project 14 out of 50 plus AI project. Without wasting time, let's get started. And if you are new to our YouTube channel, then please hit like and subscribe button for more upcoming projects. First thing first, what you need to do, just open your browser and search Kaggle. As soon as you click on search, you will redirect to the new page. Then click on first link that appears on display. Next, you have to click on sign in option. After clicking on it, you will redirect to the sign in window. Then here you can sign in with your preferred Gmail account. After clicking on it, you will redirect to your Kaggle profile. And here as you can see, I am successfully signed in into Kaggle account. Now next, click on profile button which is at right top corner. Now click on setting option. After clicking on it, you will redirect to the setting page. And here scroll it down to API section. Now click on create new token. As soon as you click on create new token, you will get a new pop-up window. In my case, I already generated a token, then I can click on continue. In your case, whatever permission that it wants, click on yes. And finally, download the kaggle.json file. In kaggle.json file, you will get username along with key. Now click on three lines which is at left top corner. Now here you can click on dataset and whatever dataset that you want, type in search bar and click on search button. As soon as you click on search, you will get the dataset. Click on the icon of the dataset. After clicking on it, you will redirect to the dataset page. Here as soon as you click on download button, you will get dataset path as well as download options. And here you don't need to copy the entire data path. You only need to copy down those content which is inside the double quotation mark. Now quickly I used to move on to the next step. And here as you can see, first I used to install Kaggle API package. In my case it is already installed, so I can quickly move on to the next step. Next I used to set up our Kaggle credential. For this first I used to import OS. This is Python built-in OS module which provide function for interacting with operating system. It is commonly used for environment variable, file as well as directory operation and other OS related tasks. Now os.env with index Kaggle underscore username. I used to mention my username. This line of code assign the Kaggle username to the environment variable. Again with the usage of os.env with index Kaggle underscore key. Here I used to pass my Kaggle key. Similarly, this line of code will assign Kaggle key to the environment variable. And together these two things are needed to authenticate request to the Kaggle dataset, which I got earlier from kaggle.json file. After running the code, I will quickly move on to the next step where I used to import libraries and authentication. And here as you can see, from kaggle.api.kaggle_API_extended, I used to import Kaggle API. The code will provide a method to interact with Kaggle API. Next I used to create an instance of Kaggle API class. which named as API, and with the usage of API.authentication method, I used to establish a connection with Kaggle API. Now after running the code, I will quickly move on to the next step where I used to unzip the dataset. For this, first I used to define a variable called dataset where I used to pass data path, which is I copied earlier from Kaggle. Next, with the usage of API.dataset_download_file where I used to pass dataset, path and unzip is equal to true. This line of code will extract dataset file from Kaggle to the current directory of the Google Colab. After running the code, I successfully fetched the data from a particular dataset URL. Quickly, I used to move on to the next step where I used to load the dataset into a Panda data frame. So for this, first I used to import pandas as PD, which is a Python library that is used for data extraction as well as manipulation. Now next I used to define a variable called csv_files. Next, with the usage of os.listdir function, I used to list out all files in a current working directory. Next, with the usage of list comprehension along with conditional statement and loop, I used to filter out CSV file. Then whatever list of file that comes after it, it will be stored in csv_file variable. Then csv_files with index 0, I used to extract the first CSV file from the current directory, and it will be stored in csv_file variable. Next, I used to take a print of the CSV file with the usage of print function, where I used to pass csv_file inside the curly braces. Next, I used to load data into a data frame. This first I used to define a variable called df, and with the usage of pd.read_csv where I used to pass csv_file. Now next, in order to display all columns clearly, I used to call pd.set_option function where I pass display.max_column with none, and with the usage of pd.set_option function where I used to pass display.width, 1000. This line of code will ensure that output will fit under 1000 character. And finally, with the usage of df.head function, I used to print the top 5 rows of the dataset. And finally, here you can see the dataset file name along with their top 5 rows of the dataset. Now quickly I move on to the next step where I used to convert this dataset into a machine learning web application using Gradio. Now here what you need to do, just install all the required libraries which include Gradio, scikit-learn and pandas. Now quickly I move on to the next step where I used to import all the necessary libraries which is required for this project. Now here as you can see, I used to import pandas as PD, which is used for data manipulation. Now from sklearn.model_selection I used to import train_test_split. This is used to prevent data from leakage. Next, from sklearn.linear_model I used to import logistic regression. This is machine learning algorithm suitable for binary class classification. Next, from sklearn.preprocessing I used to import label encoder. This is used to convert categorical labels into numerical values. And finally, I used to import Gradio as GR, which is useful for creating user interface for machine learning model. After running the code, I will quickly move on to the next step where I used to prepare dataset for training. Now here as you can see, first I used to drop those rows from feature column which consist missing values. The usage of df.dropNA function where I used to pass subset and assign the feature column which include age, embark and fare. Next again I used to import label encoder from sklearn.preprocessing. You don't need to import same thing again and again. Here I import intentionally. Now with the usage of label encoder.fit_transform on top of feature column, I used to assign unique integer to each category of the feature column. Now next I used to filter out feature as well as target variable. So for this, first I used to define feature as variable. Then I used to pass or feature column inside the list. Then I used to define x as variable which represent feature column, where I used to pass df with index feature. Next I used to define y as target variable where I pass df with index survive as target feature. Now next I used to split the data and train the model with the usage of logistic regression. So for this I used to import logistic regression from sklearn.linear_model. Next I used to call logistic regression class where I used to pass maximum iteration, that is 1000. This line of code will set the maximum number of iteration of data upon which logistic regression machine learning algorithm would be trained. Finally, it is going to be stored in model variable. Next, with the usage of model.fit method where I used to pass x and y, where model will learn pattern between feature variable as well as target variable. Now after running the code, and here as you can see, this code prepare a data, clean missing values, code categorical variables and select features, and finally train a logistic regression model to predict survival. Now quickly I move on to the next step where I used to define prediction function, and here as you can see with the usage of def keyword I used to define a function named as predict_survival where I used to pass number of features. Next with the usage of conditional statement I used to encode some of the features where I used to mention 1 if 6 is female else 0. Then I store it to their corresponding variable. Next I used to encode the embarked feature. For this first I used to define a variable called embarked_map. With the usage of dictionary, I used to assign unique integer to their corresponding categorical features. And finally, I used to assign this encoded feature to the embarked variable. Now quickly, I used to format the input which is required for the model. So for this, I used to define a variable called input_data, where I used to store all the feature column. Next, I used to call model.predict function where I used to pass input_data with index 0. This line of code will give the predicted result which is to be stored in prediction variable. And finally in return statement I used to mention that if prediction value is 1 then return survive, else if prediction value is 0 then return did not survive. Now after running the code I will quickly move on to the next step where I used to create user interface using gradio. Now here as you can see first I used to import gradio as gr, and with the usage of gradio I used to call interface class which is to be stored in UI variable. Then inside a class, first I used to call predict_survival function which is to be stored in fn variable. Next I used to define input which is store list of feature data and based on categorical as well as numerical feature. With the usage of gradio I used to create slider and radio on canvas. Next I used to define output as variable where I used to pass text. It will create an empty text box for the predicted result. Next I used to define title and description of this project. And finally with the usage of UI.launch function I used to deploy the code on gradio. Soon as I run the code I will get the public URL, and after clicking on it I will redirect to the public user interface. Now finally here as you can see the user interface of this project with title Titanic Survival Predictor. Now after filling all the details click on submit button, and as soon as you click on submit you will get the predicted result in the output text box. So this is how you can import data from Kaggle and transform it into a machine learning web application. I hope this video is informative. Please do like, share and subscribe for more upcoming projects. Hey guys, welcome back to the new videos of CodingPie. Today I am going to show you that how you can build machine learning web application that predict price of the diamond. This is project 15 out of 50 plus AI project series, and trust me guys, this is going to be super fun, easy and practical, where I used to explain each line of code in detail. And guys, it's a request that if you were new to our YouTube channel then please hit subscribe button. This will motivate us and push me to work on this AI project playlist. So quickly install all the required libraries which is necessary for this project, which include gradio and pandas. And here as you can see some of the files are already installed, so it says requirement already satisfied. Then quickly I used to move on to the next step where I used to import all the important libraries which is used for data handling, pre-processing and modeling and for web application. And here as you can see first I used to import pandas as PD which is used for data ingestion and as well as their manipulation. Next from sklearn.model_selection I used to import train_test_split function. This function is used to split dataset into train dataset and test dataset. And this function is very important to prevent data from leakage. Then from sklearn.preprocessing I used to import standard scaler and ordinal encoder. And if we gonna talk about standard scaler, which is a pre-processing tool used in machine learning to normalize the numerical feature. It ensures that each feature column has mean of 0 and standard deviation of 1. It means that standard scaler does not scale the values directly into the range of 0 and 1. Now next is ordinal encoder, which is used to convert categorical values into numerical representation. It will assign unique integer to each category in a feature column. And this is very important because ML model only understand number instead of features. Next from sklearn.compose I used to import column transformer. This class will help to combine multiple pre-processing steps together. Next from sklearn.pipeline I used to import pipeline. This will automate the process of data transformation and model training. And this will ensure that data get clean, converted and trained in a single streamlined operation. Next, from sklearn.ensemble, I used to import random forest regressor, which is a powerful machine learning model that make prediction with the usage of multiple decision tree. And finally, I used to import gradio as gr, which allow us to turn ML model into web application instantly. Now after running the code, I will quickly move on to the next step where I used to load dataset. Now here, as you can see, first I used to import files from google.colab. Then with the usage of file.upload function, I used to upload dataset to Google Colab and store it to the uploaded variable. Next, with the usage of pd.read_csv, where I used to put diamond.csv file. This line of code is used to load dataset from Google Colab and convert it into a data frame. Then whatever value that comes after it, it will be stored in data variable. Next, with the usage of data.head function, I used to display the top 5 rows of the dataset. And finally here, as you can see, the different features of the dataset, which include caret, cut, color, clarity, depth, table and size. These are called feature column, which is required to predict the price of the diamond. Now quickly I move on to the next step where I used to prepare target variable as well as feature variable. So with the usage of data.drop function, where I used to pass price, access is equal to 1, I used to remove price column from dataset and keeping only the input features. And here access is equal to 1 specify that column wise removal should take place. Then whatever value that comes after it, it is to be stored in x variable. Next, data with index price, I used to filter dot price column, which is our target feature, and it is to be stored in y variable. Next, from feature variable, I used to separate out categorical column and numerical column. So with the usage of x.select_data types, where I used to pass object under the round bracket dot columns, this line of code is used to filter dot categorical column from feature variable, and then whatever features that comes from it is to be stored in categorical_calls variable. Next, with the usage of x.select_data types, where I used to pass float, int inside the list under the round bracket dot columns. This line of code is used to extract numerical features from feature variable. Then whatever value that comes after it, it is to be stored in numerical_calls variable. The identification of categorical and numerical column is important in order to perform encoding on top of categorical features and scaling on top of numerical features. Now quickly I move on to the next step where I used to create pre-processing pipeline. And here, as you can see, with the usage of column transformer class, where I used to pass list of operation on top of feature data. So as you can see here, that standard scalar is going to be performed on top of numerical columns, which are used to normalize the data of numerical columns and makes the value centered around 0 with standard deviation 1. Next is ordinal encoder, which is going to be performed on top of categorical feature columns. And as I said earlier, that it will transform categorical data into numerical labels. And finally, this pre-processing pipeline is going to be stored in preprocessor variable. Now quickly I move on to the next step where I used to build full pipeline with model. And here, as you can see, with the usage of pipeline, which is a tool in scikit-learn that automate the machine learning workflow. Now inside the round bracket, where I used to mention the list of steps, where I used to mention preprocessor as preprocessor and regressor as random forest regressor. And finally the pipeline will chain together the pre-processing step and the model into a single structure. This line of code ensures that data transformation and model training happens in single executions. Now quickly I move on to the next step where I used to train the model exactly. So for this, first I used to split the dataset into train dataset and test dataset with the usage of train_test_split function. Here I used to pass feature variable as x, target variable as y, test_size is equal to 0.02, which represent test data would be 20%. Then in order to get rid of shuffling, I used to pass random_state is equal to 32, and whatever value that comes after it, it is to be stored in their corresponding variable, which include x_train, x_test, y_train, y_test. Now quickly I used to fit the model on top of x_train data and y_train data. The usage of model.fit function, where I used to pass x_train, y_train variable. After running the code, finally here as you can see the machine learning flowchart which represent the pipeline, and inside that there is a processor that perform column transformation with the usage of standard scalar and ordinal encoder on top of numerical as well as categorical features. And finally there is a random forest regressor which is to be trained on top of numerical and categorical encoded features. Now quickly I move on to the next step where I used to define prediction function for gradio. This function is quite important in order to predict the output based on several features. So with the usage of def keyword, I used to define a function called predict, where I used to pass all feature column as parameter. Then I used to map the list of feature variable with the usage of dictionary, and then I used to convert it into a data frame with the usage of pd.dataframe function. Then I used to store it input underscore data variable. Next, with the usage of model.predict function, where I used to pass input underscore data with index 0. This line of code is used to call trained machine learning model, that is random forest regressor, to predict the output based on input data. And whatever value that comes after it, it is to be stored in prediction variable. Next, in return statement with the usage of fstring, I used to call prediction variable along with round function inside the curly braces. Round function will round off the prediction value up to 2 decimal point. Now quickly I move on to the next step where I used to create user interface with the usage of gradio. And here, as you can see, first I used to define a variable called interface. Then with the usage of gr.interface class, I used to create an interactive web application using gradio. Next, inside the class, I used to define a variable called fn, where I used to call predict function. Then I used to define another variable, that is input, where I used to pass list of slider and radio as per as categorical and numerical input features. Next, I used to define output as variable, where I pass text. And finally, I used to define title of this project, that is diamond price predictor. And then with the usage of interface.launch function, I used to deploy the code on gradio. And as soon as I run the code, I will get the public URL, and after clicking on it, I will redirect to the public user interface. Now quickly fill up all the details and click on submit button. And as soon as you will click on submit, you will get the predicted result. So this is how you can build machine learning web application that predict the price of the diamond. I hope this video is informative. Please do like, share and subscribe for more upcoming projects.